and look for the descriptions that you will find out in my presentation. So what I have here, I have a diagram on which there is a depiction of the architecture of the web-based system. So what we have here? We have here a RESTful service which connects to the database server and can connect to any other external system if business logic of that service requires such an action. To access this RESTful web service, you can access it through a custom client, the client that sends a request using HTTP protocol and receive back the responses usually formatted in JSON. However, it's possible also to use another kind of the serialization, which is XML. And you can also work with RESTful web service having intermediate layer. You can have a front-end system which talks directly with the RESTful web service, exchanging the data serialized in JSONs. However, it prepares the views for the client application. So the client application just look for forms and receive HTML document and display these forms on the client view. So as you may see, RESTful services are, how to say, very generic. They can be used directly by some clients, and they can be used also by the other systems, so-called front-end systems, which consume REST APIs responses and delivers the HTML documents directly to the client application, which is displayed in the web browser of the client. However, sometimes people are also implementing a bit different schema. The application, in fact, might deliver directly HTML documents to the client application, and this can be done with, for example, Spring MVC, so the framework in which these HTML documents are prepared and sent back to the client upon request. However, underneath, the content of a Spring MVC might send the request to the REST API controller, which will deliver the responses according to the business logic hidden behind the implementation. And we already talked during the lecture that the controller, this is like a first layer of the implementation of the service. And the controller may ask the services to deliver the responses or to compute the responses, and the services might use repositories in order to persist data and retrieve data from the data storage layer. So in general, as you may see, the number of variants which are nowadays used during the implementation of web service is quite big, and many approaches to build such an applications are used. In most cases, if we talk about various abstraction layers, we should also talk about the configuration. Most of the frameworks, whenever they enter particular layer and they offer the functions of particular entities or particular components of this layer, these components usually are configured somehow. And we talked already that in a Spring Boot application, the configuration can be delivered as a separate XML file as a separate properties files. They can be delivered in annotations and which are compiled in particular classes. So this is an overview, and in this overview you can see also that the client application, when it asks the application server for the data, it asks using some protocol, and this is the HTTP protocol, and it uses the get, pod, post, patch, delete methods usually. There are some other methods which are also supported by the HTTP protocol, but like option. But these methods are usually to retrieve, are used to retrieve information about the services offered by the web service, and are really rarely used in an implementation of common web services. Among the others, in that architecture, we can put also another layer. So let me go back to this part, okay? So can you see my mouse pointer? Right?
Yes.
Yes. Okay, so I can point out on the parts I would like to discuss. So we said that there is an application layer, there is where we have the REST controller, and we have a domain layer, where we have the services and the repositories and so on. And in between services and repositories, or in between application and domain layer, you might have also something that is called cache. So REST controller not necessarily must deliver queries to the repository through services on every request. Sometimes, if the request sent by the clients repeat often, so instead of retrieving the same data every time, that data can be held or can be captured and kept in a cache in order to deliver them faster, not in order to limit the number of the requests that are sent to the databases. So this layer can be inserted in between application and domain layer, or inside the domain layer, and can be also standard and is also standardized. And to play with the cache, you can use also, how to say, several approaches depending on which architecture you choose to implement your web service. You have, how to say, some specific ways of attaching cache to your application. So here is, for example, the example of the cache. Let me check. That is, so there is the description how to play with the cache. Instead of to retrieve every time the entity from the database, from the service, you can also put in the middle a cache control. And this cache control will allow you to store or to retrieve the entities which were already loaded by your application. So as you may see, this is in between REST controller and retrieving the data from the repositories. So here is the place for the cache control, and how to configure this cache control and how to play with it. You can read in that description. By the way, if you are using Hibernate, Hibernate itself has some cache control already within the framework. And but this is another quite a big topic, and we have no time to discuss it in details during that lecture. However, to give you some hints, I delivered here the links to the tutorials under which you can familiarize yourself with that concept, with the concept of the caches. If you want to have a, how to say, very efficient application, if you want to deliver responses fast, so the cache is one of the paths you should follow. Okay, so knowing that, we can talk about the, how to say, the front and then the back end from the point of view of a developer. And some of the students which attend that course, and I have in other groups, already works for the IT companies. And some of them has specialized in particular technologies. So whenever you hear about front end, or whenever you hear about back end, you should immediately match these terms onto the technologies or the kind of the programming. So we can say that we have front-end programmers, we have back-end programmers, and sometimes you can hear also that the companies look for full stack developer. So full stack developer is, how to say, the master of both. It can write the front end and it can write the back end as well. So these terms maybe now will be clear, and if you will look for a job in the future, so front-end development and back-end development are quite different, and if you are a master of both, you are a full-stack developer. And back-end programming, this is what we do already during that lecture. All the most of the design patterns that were already discussed, and most of my examples were related to backend programming. And Spring Boot just delivers you the possibility of building such backends. However, there is a Spring MVC in which you will have also some parts of front-end programming, because you use there the templates of HTML documents that are sent to the client application in order to display them in a web browser. So this is not the whole truth that Spring is used only for a backend programming. Some parts of the front-end programming you will find also there. And regarding the front-end programming, most of the, how to say, final source code that is sent to the web browser is in JavaScript. Even if you are working in such frameworks like an Angular or final output which will be sent to the web browser will be in JavaScript. And JavaScript is a language which is interpreted language. It means, and it is not is a script language. It means that it's not strongly typed. You can declare variables and you can assign to these variables various objects, and it will be all right. The interpreter of the scripts will find out what kind of the object is assigned to that variable, and it will handle that object correctly. And writing JavaScript is, how to say, another art. It's another language, and this language is bound to the views in a very specific way. And building application with front ends usually or was done using AngularJS, and my example are in AngularJS. However, most of the nowadays application just switch to Angular. This is what I already explained during my during the laboratories last time. So, however, before going further into this Angular and AngularJS, let me refer again to the RESTful applications. So on my web page, you will find out some links like RESTful web service and link to related resources and REST API design tutorial. Please go to these links and read the tutorials you will find there. So why I am asking you for doing that? Because I observed during the labs that and maybe it was my mistake at the beginning of that semester that I do not put more attention on describing all the, how to say, the patterns that are used when implementing RESTful services. So some of them I will discuss just now. As you may know, the playing with RESTful applications really rely on using methods of HTTP protocol. And I've seen that in your description of your of the REST APIs of your applications, you used put and post methods, just not considering what are the patterns or approaches by which these methods should be used. So here is the example of the using a put method. So the put method is called in order to create entity on the server side. Whenever you want to create a new object, you should use the put method. And put method is called with the particular, might be called with a particular ID. If it is so, if you put an ID, if you call the put method with URL in which you put an additional ID, it means that you create a new entity on the server side with that kind of the ID. So what is important at that point is that when you switch or you use that approach, so your application will be responsible for assigning IDs to your objects. This is, how to say, important thing. All data you preserve in your data storage must be identified with unique identifiers. And depending on the strategy you selected, these identifiers can be assigned by your business logic inside the server application, or these IDs can be assigned to your object by the data storage. So this is, how to say, a bit different, all right? So if you are asking to send or to create a new object on your server side using put method, it means that you agree to assign the IDs by the your business logic. However, if you want to create a resource, create a new object on your server side using post method, the thing is different. You're sending the post request under the endpoint without specifying its ID. So you just call the post with attach the JSON, in which JSON you have the attributes of your object, and this request must be handled by your web service in that way that it will enter the entity into the database, and then it will retrieve the ID of that object, and it will send back that ID in the response. So this is what does my student app. My student app uses POS to send to create a new students on the server side, and I wrote my student app in that way that the object that is sent in the response will include ID of which was assigned by the database. Right? So this is the difference between using put and the post method. And there is another thing. We have also a patch method. The patch method can be used also to modify existing entities on the server side. However, the thing is different. A patch is used for updates, while the put insert a completely new object. So the put updates the whole object, while the patch method is used to update some of the attributes of the existing object. So this is the difference, the difference of the uses of both this method, right? Patch creates a totally new object, while the patch is used to update some parts of the object. So you can read in this tutorial on RapidAPI.com more explanation on how to use this put and patch and what are the differences. However, so as you may see, the post, put, and patch methods of HTTP protocol are used mainly to change data on the server side, while the get methods are used just to retrieve data from the server side. And regarding the access to the data, so it's another thing that I did not explain well yet. This is a so-called resource-oriented architecture. Whenever you are talking about RESTful web services, you really talk about resource-oriented architecture, because the rules or patterns which are declared here should be applied when designing endpoints of your web service. So what are these rules and how to apply these rules when designing your REST services? So here is a link to the resource. This one. Here is the example. Look, on that chart, I have serialized responses from my web service. I have a member, so if I send a GET request against the member endpoint, I should receive back this kind of JSON or this kind of the object. If I ask for the order, so I should receive the order. If I ask for orders, it means order histories, the list of all orders. So here is the list of all orders. And if I ask for authentication, so here is the result about the authentication. What is important here? Look, whenever you call for the object which has some dependencies with the other object, according to resource-oriented architecture, okay, the object itself presents all its attributes, but all the dependencies which exist are delivered here as links. So if my order has an owner, so this owner is depicted in this links block. It is depicted by two attributes. So each object inside the links RI has rel and href attributes. Rel, it is a name of the, how to say, this is the type of the object we are referring to, and href is an URL. It might be also an just simple ID, but usually this is a URL to the endpoint under which you can retrieve that object. So the idea is that when you are working with resource-oriented architecture, you should have the endpoints under which you retrieve particular kinds of the objects. And if these objects are related to the other objects, so you should deliver the dependencies to these objects using links and rel and href. Sometimes in different tutorials, you find out that the names of these attributes are, how to say, are a bit different. However, usually there is an attribute which refers to the type, and there is an attribute which refers to the URL under which a particular object of that type can be retrieved from. So this is the idea. And some of you, when were trying to design your REST APIs, just, how to say, was lost completely in that part, how to deliver the information about existing dependencies. And telling the truth, I did not give you any clue at the beginning, because my students app application is very simple. It has no dependencies in it. The objects I am asking are just singular, simple objects without any relations. But in the more complex case, when you have a bigger data model and with many dependencies, you should handle them in that way. And there is a quite nice tutorial like that one, designing REST APIs. And in that tutorial, you have the explanation how to design REST APIs using this resource-oriented architecture approach. Whenever you are talking about one object, one type of the objects which might have some relation to the other kinds of the objects, so you can declare the endpoint where you put an ID of that object as an attribute, and these other relations you get from additional endpoints. So as you may see, that in that way you can access all these dependent tables and all this dependent data from well-designed endpoints. Inside that tutorial, it is written that the objects which are delivered to in the response might be serialized in XML or JSON format, and the rest of this tutorial shows the examples which are serialized into XML. However, this is not a big deal. As you may see, here we have also in the objects that are retrieved as the response, the part in that XML which is a link, which has a rel, and which has a href parts, which refer to the type and the endpoint under which you can retrieve additional dependent object. What is also important here is that, as you may see, the URL which are delivered here are partial URL. These are relative. If your service works on a particular host under particular path, so with respect to that path, you should look for this endpoint. So this path, this partial URL should be attached to the service URL in order to receive a full URL of the endpoint under which you should send requests in order to retrieve the information about new or dependent objects. So here are explanation how to deal with a single resource, how to deal if you want to deliver a collection of the resources, and so on. Okay, so it's also important when you look on this example of the responses, it's important to see that what you have here is not exactly what you have in your database. Here is the collection of links. So if you want, if you would like to declare in your YAML description of OpenAPI, so to declare the data type or the schema for that kind of the response, so that schema will include the description of a new data type which is called configurations, which has a configuration, and the configuration has attributes, has a sub-object link, which has attributes rel and href. So as you may see, here is something which does not match the structure of your database. So now it's time to talk about the entity to DTO conversion, because what you have inside your model or inside your schema, which is used in order to serialize and deserialized objects sent to and from service, this is so-called data transfer object. So the model in which you declare objects used to transmit data between endpoint and the client. And you can match this DTO into entities according to using some specific libraries. In that tutorial I am displaying just now, we have a reference to Model Mapper. Model Mapper is a library written, it's for Java 8, but it works also with Java 11. So this is a library that can, map a model of DTO to the model of entity with some, business logic. It's quite easy to convert one type to the other using just a simple map method. So let's come back to this example. If you want to play with this library inside your dependencies in Maven specification, in POM XML file, you should add Model Mapper dependency. Once you have it, you can work with that mapper. However, there is one point I must refer. Whenever you change the POM XML file, please remember that these changes must be accepted or must be processed by your IDE, by your environment, by your tools. So whenever you upload or modify POM XML, you should update the project. You should run a Maven update otherwise it will not reflect the changes inside your project. Okay, so every time you change the POM, you add new dependencies, you remove dependencies, whatever you do inside the POM, you should update the whole project. And afterwards, you will be able to run and compile, and everything should go correctly. So going back to this mapping, the mapper which is offered by the framework is an object of the type model mapper. So to get it inside your application, you should, and Spring Boot application, you should declare it as a bean. So, and if you have a model mapper method that returns model mapper, so it means that when your Spring Boot application starts, it will create a singleton, and this singleton will be available whenever it will be needed, and you can use this mapper inside your application in that place where it will be required. So let's see how we can map one model into the other. So here is post DTO. So this is the data type which is used to exchange data between the client and the service. You could put a schema in your description of OpenAPI, which will include this ID, title, URL, date, and user attributes. However, as you may see, this post-DTO has some additional features which were implemented in it. This is also something that I've seen in your design. There was a problem of conversion of specific data types, and these data types are like the types used to store the date and hours, the time, and how to say, the values which are language sensitive, because in different languages the dates might be interpreted differently. So usually Americans change the date and a month in the order the dates are displayed. So to handle that problem, inside this post-DTO class, it was declared and a singleton, which is a simple data format. And this singleton will be used to convert strings which will be sent through a REST endpoint to my controller, and vice versa, to convert the data of my post-DTO to the string which will be later used to send the JSONs back to the customer, to the client. Okay, so simple data format just will interpret the incoming string in that way that the first 4 fields will be the year and the age and M, which comes here. This is a pattern that tells us about hours and minutes. So get submission date converted. Whenever it takes the string, it will convert this to the proper data type, and vice versa. If you have the date and time zone, you can convert the date to the proper format. Okay, so here are these tools which work together with that formatter, and this kind of the formatting is delivered, is existing in Java SDK. So what we have next? Under service layer, we can have some kinds of the data input. My get post method, the method which is a controller method, will receive these attributes from the request. So the framework will just pass me this data here. And I can then play with, sorry, this is the service layer. Controller is below. In the service layer, you are just sending find by user, and you are retrieving the entities from your storage. Under the controller layer, you should, handle the data conversion. So whenever you have the post method, get post, it means that here your Spring Boot framework will deliver the attributes of your call. And these attributes should be converted into DTO in order to retrieve proper data. So let me explain again. Your controller is a method that captures incoming request. This get post method will have some attributes. So in order to handle that request, you should retrieve the data from the service. So the service retrieve the data according to entered attributes of your request. And having retrieved that data, this data are converted into the stream, and each entity that came from the service is converted to DTO, and after the conversion is collected into the list, and finally that list is a list of DTO which is returned by the controller method. This kind of the programming, you see, there is a stream.map.collect, and collector to list is something that is called functional programming in Java. So this is this kind of the programming came together with Lambda expression in Java language, and it was available starting from Java JDK 1.8. And nowadays, most of the programmers just switch to that kind of the programming. It's nothing, strange in this kind of the programming. It's just a different notion. Instead of running each of the methods separately, these methods are called in a sequence and separated by the dots, and the data are processed in streams. So this is in general, okay? Post service is a service that retrieves data from the database. This kind of the response, which is retrieved from the service, is an entity or list of objects which are stored in the database. And to send back the objects which are used to transfer the data to the client, you need to convert them to DTO. So this is done here, convert to DTO. And whenever you return data, you must to convert the retrieve data to DTO. However, you can also work in another way. Whenever you receive DTO, data object, which is sent as a part of your request body in some post method, so then you should convert this object into entity in order to store it in the storage of your database, in order to pass that object to the service method. And as you may see, this crucial convert to DTO and convert to entity are just simple method that takes one type of the object and produce the other kinds of the object. And using this object mapper, it is quite simple to implement these methods. It's done in that way that whenever you are sending the entity and you are to convert that entity into DTO object, you are using model mapper and map method. The map method gets this entity object and gets the post DTO class, and in the response it gives you the post DTO object. Just simple one line that converts one to the other. If you want to update some parts of this DTO, because this post DTO might have more fields than the original entity class, so you must fill in the rest of this DTO part with missing values. So this is a set method which is used here to fill in these missing parts. Okay, so this is in general how it can be done through the object mapper, through the model mapper. There are also other frameworks, and you can find the tutorials how to map DTO to the entity and vice versa using different approaches. So depending on which tool you will use, you will end up with a different way of coding such a conversion. So please refer to the documentation of your library in order to familiarize yourself with all the details of such a conversion. Because in general, this map that was presented here is very simple, right? It just tries to find out the fields in one class and map them to the fields in the other class. Just rewrite the content of these fields into the other object. However, it's possible also to do some more modifications, so adjustments. You can configure the strategy by which this mapping should be done. So this kind of the configurations and this kind of matching strategies you can use usually are the part that might be configured when you are using particular framework using some methods. Here, by the conventions which are already implemented are selected by setting a proper strategy, and the strategies which are implemented are here listed. So in this model mapper, you have this kind of the strategies of rewriting from the one the data from the one type to the data written in the other type. All right, so this was the model mapper and mapping entity to DTO. And I will close these parts which I already discussed. Put versus patch has been already discussed. And let's go. Let's dive also to the parts of the implementation which are related to AngularJS and Angular, just to the implementation of your view. So we already know, okay, that our application might have the view, and the view can be a client to your backend. So what it means, the client of your backend? It means that inside a view, you must send the request to your endpoints, and the object you retrieve, this DTO object, you must represent somehow on the screen. So here I am showing now the simple application which has a simple counter API. Inside this counter API, I have just a few methods. I have method add to counter and I have get counter. Just two simple methods. One which increments the counter which is held inside the service at the get counter is the method that is used to retrieve data, to retrieve the value of that counter. So just simple two methods, and I can access this method on a web page. So the web page can be implemented like here. So you on the right hand side you can see that the web page will be rendered as in that form. So comments, label, and the field to entering data, the button, and the next label. So in fact, this is what I have inside my HTML document. Inside my HTML document, I have a header, and I have a div component, and inside the div component, I have the paragraph, I have the button, and I have here again the header, but on the level 2. So maybe it would be maybe better not to put the headers here, but anyway, it was done, as you may see, using the headers. So what I have here inside my implementation or inside my HTML document, I have also some additional fields. I have, for example, a script. This is also interesting, and a script here. And as you may see, I attach these nodes of my HTML document inside head, because the HTML document has a head and a body. The head is something that is loaded when you enter the page for the first time, and the body is something that will be displayed when you come back to that page during the same session under the web browser. So in the body is just the content that is displayed, but in head it is like a settings. So what I have here is I am asking my web browser, which will display this web page, to load Java scripts, to load at first the library and then my own JavaScript. Can you see, right? These are just comments or nodes inside my document in which I specify that I will work with some scripts. It is also interesting here, see that Angular that I am using is 1.7.8, is an old version of this Angular, and this Angular is will be downloaded from that link. Telling the truth, this is not a correct way of implementing web applications. Whenever you are using libraries or other kind of the scripts inside your application, they should be, installed locally. What it means? If I am using the link, like here, using URL to external service, I am not the owner of that service. So someone can, in a bad case, substitute this script with the other script, or can inject some viruses in these scripts, so it can infect my application. So from the security reason, the people usually download these scripts or these libraries to their own server side, and they serve these libraries locally, not allowing to download scripts from the external resources. So having that I am not very worried about that application. Google APIs are usually, how to say, trusted sources. However, in the production environment, this should be changed. And I have a counter demo. All the methods, all the variables which are used when writing Angular JS scripts. Here I have also some interesting parts in my design. Namely, I have parts of my HTML document which are in double curly braces. This kind of the notion is a notion of the directives. Whenever you have the directive, this directive will be filled in or will be injected with some data that will be calculated by the JavaScripts. So what I want to say is that this is the description of the view. Inside the description, I have some parts which will be filled in by the JavaScripts, and finally the browser will display the data which will be inserted instead of these directives. I have also here an additional part, namely my root node of my HTML has an attribute ng-app, and this app is called to-do app. What it means? In every JavaScript framework, the similar, you can insert in attributes of HTTP protocol some values. And HTML standard is a standard in which clients or developers are allowed to put any kind of the attributes inside the nodes of the documents. Okay, so this is another point I want to memorize. The HTML specification, in fact, XHTML, is a specification that defines what kind of the nodes you can enter inside your document. So it has its own XML schema, under which you can validate the content of this document. However, and the names of the nodes are standardized. This HT, H2, this div, this P, this button, and so on are nodes which are declared in the HTML specification. However, HTML specification does not put any restriction to the attributes of these nodes that are used by the users. So you can put anything. So therefore, this HTML document has ng-app here, and the browsers will accept it. If I don't put any scripts declaration here, and I will open just this HTML in the browser, I will see nothing. Okay, I will see only these parts without any actions related to interpretation of these attributes. However, if you have the scripts, JavaScripts, and if you run your HTML document in a browser, so these scripts will be loaded by the browser, and they will be run, and they will interpret all these directives which are written inside your HTML document, and the way they will interpret or handle these directives will depend on the attributes of the nodes in which these directives appear. Because every node which is in HTML document, if you are using AngularJS, might have a controller assigned to it. So this is what we have here. In general, all that HTML document is an Angular application, and this Angular library and scripts which I'm using are declared here. And then I am saying that this particular node will be handled by this particular controller. And the same will repeat in Angular in the TypeScript. The idea hidden behind this is identical. If you have the nodes will be handled by the controller. This controller is a bridge between the view, which is declared in the HTML document, and the business logic, which is declared in the JavaScript, which is handled by the controller. Okay, so ng controller will handle what is inside, and this ng controller should offer me add to counter method, and should offer me also the counter variable with attribute value, which should be retrieved from the context. So let's see how this JavaScript counter demo looks like. So I have here the declaration that I have the module, and this module has a controller, and the name of this controller is a counter controller, and the implementation of that controller is here in that function. That function starts here and ends at the very end, right? And ends here. Whatever is inside is the implementation of that controller. So now there should be, how to say, the tutor or a separate course on the JavaScript. But to make the things, how to say, easier or not going into detail, let me explain. This function, which is here, takes two attributes, scope and HTTP. When the script starts, these attributes will be delivered to you. The scope is like the name of this attribute means the scope. So this is a kind of the context in which you can place, in which you can store your functions, your classes, your variables, whatever you want to use. It can be stored in a scope. Scope is like a container on whatever you are going to use inside your controller. And there is a nice slide, or nice, where it is, a nice, not here, let's come back, nice slide. I think that one, and sorry, not that one. This and this. So the very nice tutorial about AngularJS you will find out under that link, and inside that specification, there is one nice diagram, which it's shown here. The scope is the, how to say, the part of your application that glue a controller and a view. You can modify the scope inside your controller, and you can access the content of that scope inside the view. So this is how it works in JavaScript. So this scope will be injected when by the environment when your application start. And you can play with that scope. And as you may see, the HTTP will be also injected inside your application, so you can use a HTTP object in order to call its methods. The HTTP object is defined in AngularJS library, so it will be given to you once you enter that control. So what I have here, this is like a program which will be executed line by line. So at first, when the control starts, it will run the GET request. And this GET request, when it succeeds, it will deliver you the response. And again, here you have something like injection. The response which you receive can be used to extract the data from that response. And the data, in fact, from my response will be only one value. It will be a counter. So I assign that counter directly to the counter variable which will exist in my scope. So JavaScript is, as I said, a language in which you can declare on the fly the variables, and after the declaration, the variables will exist. This is not like in Java that first you must declare variable and then assign the value to it. These variables can be declared and assigned on fly and will exist afterwards. So once I declare that my scope dot counter has such a variable, so this variable will be existing inside my scope. So this is like calling the constructor. Okay, the object will be created here, and it will be, and the value which will be assigned to it will be taken from the response. And I have also here next step. Okay, whenever I enter that controller will assign to the increment value 1. And next, this is another line which will be executed during accessing that control. This is initialization of add to counter, let's say, member variable of the scope. However, this is not a single variable. What we have here is that add to counter will be a function. So this is a special syntax of JavaScript that declaring a functions means, or creating a function means that you declare the name of the function and you run the function as a keyword and you declare the content of that function just afterwards. So what I have here is that add to counter will be something that will start with the post against the service. Under successful operation, I will put on the screen, because console log is just a login information which will print on a console, and afterwards I will send the get method under the counter endpoint, and I will respond with the response will be used to update the counter inside the scope. So see what I have here. Add to counter is a function that will post some data. What data? This is an object. Okay. What is this object? This is the value of the increment inside my scope. Okay. So this object is a JSON object. Okay. It has a value, and the value is taken from increment variable, which is declared here above. So this object will be sent under that endpoint. So after sending that data, I want to update the content of my view. Therefore, I am asking a counter for a current version of current value of that counter, and I will store this response in response data in a counter field on my, which is accessible on my scope. And that's all, right? My controller first gets the counter and puts inside the data and assign an increment to it. And add to counter is a function that will call the counter endpoint using the post method with the object which is created here, and afterwards, after successful response, it will update the counter value which exists within the scope of my application. Just such execution. So when I run this application, so I will run the Spring Boot application, and this script will be loaded. So I can go to the localhost 8080, and I will see this like here. Whenever, okay, so maybe, to start from the scratch, I will stop my service, and I will run it again. Okay, and I will refresh my web page, and here is what I got. Okay, at the beginning, my counter was equals to 0, and my initial increment was set to 1. So I can display the source code of my web page. So this is the view which is displayed here. As you may see, this is the view which is exactly as the view implemented inside my JavaScript. It means that the web browser must interpret all this ng controller and so on, this part of the AngularJS using AngularJS script. What is interesting is that if you store this web page as an HTML web page, okay, I will store it, and we come switch to the storage HTML. So look how this HTML looks like after storing into the HTML document on my disk. Okay, it is a bit different than what we have seen previously. No, it's okay. It's all the same. Okay, there is a counter, there are ng attributes. Okay, I thought that I will receive something else. It doesn't matter. We will return to that part later on when we start semantic technologies. You will see what I meant telling store the content of this page, web page, as an original page. I will try again. Okay, okay, index HTML. Now I will store it, and I will switch to index HTML. Okay, look what I have here. Can you see? Okay, this is what I wanted to show you. This is my web page, which is displayed in a browser. If I look on the source code of that web page, I will see the original HTML document that I implemented in my AngularJS. However, the document which is displayed really, this document, which is displayed here by the browser, is a document which is that one. It is a HTML, it has some additional features, char sets, it has the sources scripts here, and it has also body, and there is a controller. But here, instead of directives in curly braces, I have already values. Can you see? I have really ready values which are delivered already, which are calculated by the JavaScript. And I have also script Mendeley because my browser has installed. I have in my browser installed a Mendeley plugin, so my browser just attach to the web pages the Mendeley script just to handle the data which are here. But this doesn't matter at the moment. So this is the thing I wanted to point out, that the HTML documents that are really displayed are like it here. There are no more directives inside your HTML documents. Instead of directives, you have the real values. So, okay. This script works in that way that I can, for example, add I can modify increment, and I will add increment to the counter, and the current value of that counter will be displayed here. I declare, for example, -5. I press the add counter, and here is the current value. So why it is possible that here I am, after pressing the button, I am doing some on the server side, and I have immediately the result here. This is exactly thanks to my design, thanks to my scripts and the implementation. Whenever I am adding something to the counter using this add counter method, this add counter method sends the request, and immediately after receive the response or receive the current version of that counter, and assign that value to the counter variable on my inside my scope. But because my HTML document always display current value of that counter, and that button, whenever I click on it, will run add to counter method. So this is how it works. It's a bit strange from the first point of view when you start the implementation of the views using JavaScript, that it's a bit difficult to understand the stages of your application, right? What happens? So let me explain again. When your view is loaded, so your web browser will read all these scripts and will interpret all these attributes correctly. And the interpretation of these attributes is so that in my counter demo JS script, I have a declaration how the controller should work. So I have all the functions, all the variables that are used within my controller. I have a function add to counter declared, and I have also declared the field increment, and I have also declared a field a counter. Counter, increment, these are fields which are declared inside the scope at add to counter method. And on the HTML document, I am using that variables. Here I am using increment. So I match that input field will be matched to the increment field of my scope. And whenever I click on my button, I will run add to counter method. And whenever I want to display a current counter label, so afterwards I will display the counter value, which is a part of my variable declared in my controller. So that's it. You will see similar approaches or similar structures in my student app. In my students app, I have the scripts in statics, and I have students demo.js. And if you analyze that, that script, you will find out that inside the scope, I declared at first some fields. At the beginning, these fields are empty. Some of them are assigned to true and false values. And I have declared some functions. So the declaration of functions inside the script does not mean that these functions were executed. What was executed, it is just the declaration. It is assignment that this part of my scope will be a function with that kind of the body. So I have several functions being declared, and in one of the functions, like a save student, I am sending the post request against the student endpoint, and afterwards, after having successfully submitted the data, I am running the get method in order to retrieve current list of the students and store that current list inside the scope in the students variable, and so on. Right? So this works in just exactly in the same way. There are also tests, and inside the counter demo, inside the counter demo, there are no such a tests, but in general, JavaScript is a language. It's possible also to write a test inside that language. However, running tests on web-based applications is a bit different than running tests in Java-based application, because this is a different approach. So in my presentation, where it is, in my presentation, you will find out also some references to the examples, which you find out under these links. And here is the example of index.html with these controllers and so on. And there is also example of Protractor.js, and Protractor.js, this is the, the JavaScript file that can be used to run a test on your Java AngularJS application. So to run this test, you would need to use the Protractor framework. This Protractor framework is just the framework for running tests against your web applications. So I will not require from you any test in your application. However, to close the subject, I am just talking in my presentation about this framework. If you want to find out how to play with the testing of the web application and testing JavaScript application, you can just go to that web page, okay, and you see how to install this Protractor and how to run this test and how to configure all these scripts in order to make them run. And this is not the only one testing framework which is used for Angular in AngularJS application. However, this is one of popular frameworks. All right, so final part of my presentation is regarding the data model. In my student application, I used, where it is here, in my student application, I used the model class, which was generated by the Swagger, Codagen, and I attach to that model some additional attributes in order such annotations which are needed for serialization to XML. At the beginning, there were not XML root elements in my entity declaration, and as well in the students, I had no XML root and XML also in my design. However, if you want to serialize your objects into XML as an additional option to serialization to JSON, so you should use this kind of annotations and put some dependencies in your POM, dependencies to JAXB, in order to make all this serialization automatic. But this is not the point. The point is I want to discuss here is the entity, right? I have a symbol table, and my student class is an entity. In fact, I am using this entity inside my services and inside my repositories. So my services just works on student class, right? I am adding the student and I am deleting the student, and what I have here is an entity. And these entities are then used in the repositories these repositories are parameterized by that attributes, and therefore I can work directly on entities. And this long here, which is here as a second attributes of the generic JPI repository, is used to declare how to say interpret IDs of these entities within the repository. So I am assuming that the IDs will be numbers, and these numbers are already declared inside my student class. My roll number is exactly of the same type like it was declared in the repository. So you must remember that when you are playing with JPI framework, JPI repositories, whenever you have the entity and you declare the ID of that entity as being of a particular type, so this type must match then in your parameterization of your repository. Otherwise, it will not work. Okay, right. So here again, I have the application which use entities directly in controllers, services, and repositories without any mapping. However, the mapping should be done if you want to implement correctly using presented the patterns your REST API. But another point is that in your repositories, you can store data which are related to each other. And to play with the data, you need to handle the dependencies between the tables, the relationships between the tables. And in this tutorial, in this tutorial, you have the description how to declare the data structure, the schema inside your database, and then how to map that schema to the entities. What I want to say is that there are two approaches by which you can design the applications. You can start from the description of interfaces and data structure, and then having them, you can generate the database schema. Or you can work in another way. You can declare database schema first, and then you must to build your models just to match your design of your database. Nevertheless, whatever path you will choose, you must understand that if you have many-to-many relationships between the tables inside your database, it's not an easy way to map this many-to-many relationship inside your Java framework, inside your entity classes. You need to use additional annotations in order to map these relationships. And this tutorial just tells you that if you have the student that is enrolled to some courses, so your student might have a set of courses which is to which it is enrolled. Now these courses will be written in the table courses, and the relation between student and the course is a many-to-many relation. And there is another set of various annotations you can use, because on the database side, the names of the columns might be different than names of the attributes which are inside your entity classes. And to match them, you must name this you must deliver the information about the names of these particular columns using join table annotations, and so on. So if you want to play with schemas of your database, which are more complex, which has many tables related in one-to-one or one-to-many relationships, then you need to attach to your definition of entities additional annotations. So please look at them, look at the tutorials, and try to understand. There is no time today to discuss them in details. So just look at the description and try to understand how to play with these tables. On my source code, I prepared a simple JPA application. The source code of that application can be downloaded from my webpage, and here you will find out the model of the pet store. Address, owner, pet, and pet type are declared as entities inside my project, and I am using then the access method to attach this access this object inside the database. So maybe last remark, I see that the time already ended for the lecture, but a few minutes more and I will finish it completely. So please be patient. What I want to point out now is that if you are working with object relational mapping, if you are working with these entities, annotations, and Java classes, so you are working using object-oriented paradigm. So you create the objects and you are working on objects. However, what you have here on your application side is not exactly what is written to the database. So let me explain this in this simple example. Here I have an object, which is an object of an address. So I create a new address and I assign to this new address additional attributes. So I create the object, fill in with some data. This object lives inside my application. It is not yet in the database. To store that object inside the database, I must run the save method. Okay, save of my repository. There are two methods which are which can be called under the repositories. Address repo. Okay, it seems that my IntelliSense does not work here, but there is also a persist method. There are two methods in JPA repositories. Okay, there was a okay. Oh, not seen. Not there is only save. Okay. So you may find out that in other, maybe in the other kinds of the repositories, there is also a persist method and the save method. These methods are different because a save method is a method that will insert my entity into the database, and then it will retrieve that object from the repository and will give me back. So this is what was discussed already here. Let me check. This is this example. My repository, when I run a save method, inserts the entity into the database. And that save method will retrieve from my database the inserted object. So in fact, there will be two requests which will be sent against my database, two SQL requests, one which will be insert, and the second one which will be select. So this object which is returned back is an object which is taken from the database. And because this is taken from the database, my object will have an ID assigned to it. ID, which is ID existing on the repository side. As you can see that my address data type is something that has an ID. When I created my address object, I did not assign any ID to it. I just put some values which are the other attributes of my object, not ID. After save, my object will have an ID in it. So now I can bind together, or I can glue together this address to the owner. So I can create a new object with this address, and I can create the second object with this address. So now I will have the owner object which exists inside my runtime environment. It is not in database yet. To have it stored in a database, I must run save method. So afterwards, these objects will get assigned a new ID. So my constructor, which I was called when I constructed this object, was a constructor which used 0 and 0 as IDs of my new object. However, after the save method, these IDs will be updated, will be assigned by the database. So O1 and O2 after this save method will be the objects that are already stored inside my database. And so on. I can create a pet object with the owner, and after saving that pet, I will receive the object which has its own ID and that represents this object stored inside my database. What I want to say is that the schema of your database dictate the order in which you should create objects and store them inside the relational databases. So usually, at first, you stores the tables, you stores the objects which have no dependencies to the other tables, and the objects which have the dependencies to the other tables are created and stored afterwards using the first kind of the objects, this which has no dependencies. So this is how it should work. So whenever you are working with on the controllers, let me come back to the students, the repository and controller here. So whenever you implement add students method, and inside the implementation of that method, you can do whatever you want with the attributes which are sent to you without this object. You can convert them to the DTO, and having DTO, you can send them to store inside the repositories. If there are some dependencies, so your add method, for example, may inside the call another request to the repository to retrieve a missing part of the object. It can be used to retrieve all the content which is necessary to, how to say, to build the full data of your object. Because under the endpoint, you can send only, as it was shown in this tutorial on REST API tutorial. So you can send link and href as an input to your endpoint, and to how to say, to persist the object, to or to display some process object. You can extract these types and URLs in order to retrieve real objects, sending the next request to your endpoint. So what I want to say is that inside your add student controller, you can play with the objects using object-oriented programming. And whenever you are trying to retrieve data from the repositories, in that approach, you can access these repositories using repository methods. So summarizing, there were a lot of information I wanted to discuss today, and I hope that some of them you catched from my talk. I did not discuss Angular. I have the example of Angular application here. Do I have it here? I closed it already. No, not in that workspace. I showed you that it's possible to install Angular plugin to your Spring Tool suite, and you can run Angular application within your project using CodeMix. This was already shown during the labs. So if you implement your Vue using Angular, so I will be happy as well with the solutions which are written in Angular, and just show me your implementation during the labs. And if there will be any other questions regarding the how to implement these REST endpoints and how to play with this Angular, just let me know. So that's all from me for today. Any questions? No questions? Okay. No info on the chat. So thank you for your attendance, and let's meet on the labs, which are next week. See you then. Bye.
Goodbye.
Bye.